Hi all, we're on to the one lesson for this week. We've got one lesson, and for those of you in college prep math, you've got a checkpoint this week. So it'll be over all the trig stuff. So here we go. We're going to do a couple definitions, and then we're going to move on to story problems. There is no Delta math assignment for this. It'll just be on paper pencil, so you'll look at the question. It's on here. You'll do the work on a piece of paper and then upload it. Just upload it like we've done a couple times. So I wanted to say that before we go. Because this is story problems and we're doing a few of them, I'm not sure how long the video will be, but when you think you've got it, feel free to go ahead and move on. I just want to go ahead and say that. But here we go. So a couple definitions. So we're going to go ahead and define the angle of elevation. It's the angle between the horizontal and the line of sight to an object above the horizontal. So if we look at my picture, or the picture, see my little guy standing right here. Here's his line of sight. So it's out from your vision, your eyes, so your line of sight straight out. And then the angle of elevation is here, the angle from your line of sight to whatever you happen to be looking at, in this case the airplane. So that would be an angle of elevation. So sometimes in the story problems they're talking about this the elevation to the sun. Well, that's from your eyes looking up to the sun. So, or pretend your eyes are on the ground and it's a shadow and it's looking up. So we're going to kind of talk about that a little bit in a few of the problems. So that's angle of elevation. Angle of depression is the angle, very similar definition by the way, between the horizontal and the line of sight to an object beneath the horizontal. Okay, so beneath the horizontal. So if we go and look at the picture again, we've got our little guy up here still. The horizontal line, oh my gosh, is still the same line. It's still looking out from your eyes. And then it's looking down towards whatever you're looking at. In this case, it happens to be the car, and that's my angle between those two things. So I hope that helps clear this up just a little bit. So we're going to go on to the problems. I'm going to read, and then we're going to go ahead and go on. So the directions say, for each problem, make a drawing, write an equation. So look, I can't even talk right now. So for each problem, we're going to make a drawing. So we're going to do a drawing. You have to make a drawing. You're going to write the equation, and then I'm going to solve. And then in the answer, do not forget to include the units of measure, okay? So make sure that we're actually answering the question properly is basically what it's saying, okay? So in order to answer these questions, we're probably going to use SOHCAHTOA. I want to remind you of that. That's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's what we kind of did last week. And we are going to go ahead and move on. So here we go. Okay, so it says Carrie places a 10-foot ladder against a wall. So I need a wall. So here's my wall. So there's my wall. Okay, here's my ladder. So she places a 10-foot ladder against the wall. So this is a 10-foot ladder, okay, against the wall. If the ladder makes an angle, so here, let's finish. It's a right triangle, right? So hopefully, I just want to say that the building or the wall and the ground form a 90-degree angle. We're assuming that. Okay, if the ladder makes an angle of 65 degrees with level ground, so that means this angle right here, because it's making the angle with the ground, is 65 degrees, how far up the wall is the top of the ladder. So how tall is this side right here? So that's what we're looking for. So I've got a right triangle. I've got an angle and two sides, so I need to know which one of my trig functions I'm going to look at. So what do I know? Well, I know the side opposite the angle, and I know the hypotenuse. So which one is that? Well, I think that is opposite and hypotenuse, sine. So that would be sine of 65 equals x over 10. Okay, so there's my equation. I got my picture, got my equation. Now I need to solve. So I'm going to make two fractions, cross multiply. So x equals 10 times sine of 65. I put that in my calculator, and x is approximately going to equal 9.1 feet up the wall. So the ladder is 9.1 feet up the wall. And that's my answer. Done. I'm going to move to the next one. That's as easy as it is. That's it. So we're going to go ahead and move to the next one. It says a flagpole. Okay, so we're going to draw a flagpole. Here's my flagpole. And I'm pretty sure that my flagpole forms a 90-degree angle with the ground. Okay, so here's my flagpole. So flagpole, FP, flagpole. And here's my ground, okay? Cast a shadow that's 15 feet long. So here's my shadow. The shadow is not in the air. I just want to say this, shadow's not in the air, shadow's on the ground. So this is my shadow down here. And it's 15 feet, okay? The angle of elevation of the sun at this time. So angle of elevation means I'm starting here and I'm looking up, okay, is 40 degrees, okay? How tall is the flagpole? So how tall is my flagpole? So there's my information. What do I have? Well, I have the side opposite and I have the side adjacent. I do not have the hypotenuse this time, so that means that I'm going to use tangent. So that means tangent of 40 is going to equal x over 15. There's my equation. So make a fraction, cross multiply. So x is going to equal 15 tangent of 40, which is approximately 12.6 feet tall. So my flagpole is 12.6 feet tall. Good job, you guys. Okay, next one. Whew. Sorry, I don't know what's going on with my iPad here. So the next story problem says, a ramp is used for loading equipment from a dock to a ship. So I have a ramp. Here's the ship up here. The dock is down here, right? So we have a height here. Great. The ramp is 10 feet long. So my ramp is 10 feet long. Great. And the ship is 6 feet higher than the dock. So the distance between my dock and my ship is 6 feet. Okay, awesome. What is the angle of elevation of the ramp? So we want to know the upward. If this is my line of sight, here's my line of my angle of elevation. And I want to know how high it is, so I'm just going to call it x. Okay, so what sides? Again, I need to know what sides I have. Well, I have the side opposite, and I have the hypotenuse, even though I didn't mark my right angle. There we go. So that means I have sine. So I can say sine of x is going to equal 6 over 10. And now I don't want sine of x, I just want x. So how do I undo sine? Well, sine inverse. And then that means that x is approximately going to equal 36.9 degrees. Remember, I use sine inverse when I'm trying to find an angle, and I just use the regular trig functions when I'm trying to find a side. Okay, so I just wanted to throw that out at you guys again, just to remind you of that. Okay, we're going to go ahead and flip to the back side. We've got about 4 more sample problems if you still need them. Just different situations. In Southern California, there is a 6-mile section of intersection 5 that increases 2,500 feet in elevation. So I've got a road like that, and it's 6 miles long, and it increases from this point to this point, it's a 2,500 feet increase. If I could just take a little triangle part of it there. So I want to know what my angle of elevation is. So here's this. What sides do I have? I have the side opposite and my hypotenuse. So once again, I've got sine. So I'm going to say sine of x is going to equal 2,500 feet over, 6 miles. So my numerator would be in feet, but my denominator would be in miles. Can't have that. So I'm going to have to multiply how many miles. Well, let's see. How many feet in a mile? Well, there's 1 mile equals 5,280 feet. Okay, so if I take 5,280 and I multiply by 6, I'm going to get 31,680 feet. Okay, great. So I don't want sine of x, I want x. So I'm trying to find an angle, so I'm going to do the inverse. So sine inverse. So that means x is approximately going to equal 4.5 degrees. So there's my angle. Not too bad. Okay. Next, a hot air balloon is 100 feet straight above where it's planning to land. So here's a little balloon. Shh. I know it's a hot air balloon, but you know, that's my drawing skills. You guys already know that. So this is 100 feet. And Sarah, I think, is driving to meet the balloon when it lands. Okay, so Sarah's over here driving. Okay, here's Sarah in her car. Yep, okay, there's Sarah. Okay, she's driving to meet them. I know, you guys, my drawing skills are phenomenal. Just want to throw that out there. If the angle of elevation to the balloon is 35 degrees, so she looks up to the balloon, this angle is 35 degrees. How far is she from the place on the ground where the balloon will land? So how far is this distance? So what do I have? Well, I have, forgot to draw on my straight above. That means that's a right angle. So I have the side opposite and the side adjacent. So that would be tangent. So let's see, tangent of 35 equals 100 over x. Make a fraction, cross multiply. So x tangent of 35 equals 100. And I need x to be by itself, so I'm going to divide by tangent of 35. Tangent of 35. So x is approximately going to equal, let's see, 142.8 feet away. There we go. Not too bad. Okay, so next, we're almost done, guys. A couple more questions and let you guys go. Michelle is 60 feet away from a building. Okay, so here's my building. Hopefully my building forms a right angle with the ground. Okay, so she's 60 feet away. Here's Michelle. Here's my building. Okay, great. The angle of elevation to the top of the building. Oh, that is a beautiful straight line. Okay, is 41 degrees. How tall is my building? So what does that give me? Well, I've got the opposite and the adjacent. So once again, no hypotenuse, so that's tangent again. So I can say tangent of 41 equals x over 60. Make a fraction, cross multiply. X is going to equal 60 tangent of 41, which is approximately equal to 52.2 feet tall. All right, great. And then if I can slide this up, the last problem. So an airplane is descending. So an airplane, right, here's my airplane. Great. Yeah, I know. Okay, don't laugh. It's descending. Okay, it's descending to the airport. If the angle of depression from the plane, so here's the line of sight from the plane, and the angle of depression is 7 degrees, okay, and the plane is 2,000 feet, and here's the ground, so it's 2,000 feet above the ground. What is the distance from the plane to the airport? So the plane, if this is the airport, here's my distance. Ooh, we got a lot of tangent here. So there's that. So that means tangent of 7 equals 2,000 over x. Make a fraction, cross multiply. So I've got x tangent of 7 equals 2,000. Divide by tangent of 7. So x is approximately going to equal 16,288.7 feet, or 3.08 miles. And how did I get the miles? Well, I took 16,288 and divided by, I know that 1 mile, we found that out above, 1 mile equals 5,280 feet. So I just took 16,288 and divided by 5,280 and got 3.08 miles. I think that's a little easier to understand than 16,288 feet. But that's just me. Either answer is acceptable, just so you know. Okay, guys, that's it. Go ahead and, like I said, the homework will be just a sheet of story problems. You don't have to print it out because I didn't leave space in between the problems for you to do the work on. So just go ahead and read the problems, do them on a separate piece of paper, take a picture of that paper, upload it to the upload it in, and that will be it. For those of you in college prep math, you will have a checkpoint on this. It will be the last checkpoint of the year. Yeah, and I think that's it. Just so you guys know, the following week, the last week, full week of school, I guess it's still not a full week because it's 4 days, we're just going to have a little survey for you guys to do. That's all. So no math that week. It'll be time for you guys to just catch up. Anybody who wants to correct their grade or get a better grade, that'll be that time for that. So if you guys have any questions, you can always call me or email me or well, message or email me, and I'll get back to you as soon as I can. Don't forget extra credit on Alex. Yeah, I think that's about it. I will talk to you guys later. Bye.